In this video, we'll talk about simplifying rational expressions that contain complex fractions. So a complex fraction is basically a fraction within a fraction. So if you think about the overall structure of a fraction, if the numerator and/or the denominator contains a fraction, then you have what's called a complex fraction. There are really two ways that you can simplify these expressions. The idea is to simplify it so that it's just one big fraction, so you don't have those smaller fractions within. You could think about adding and subtracting in the numerator and denominator, but in this video I'm going to show you how to use the least common denominator to simplify the entire expression. So our goal again is to write as one single fraction. We're going to do that by multiplying each term in the numerator and denominator by the least common denominator of all of the smaller fractions. So let's take a look at what we have here. So we have two expressions that we're going to focus on. Let's take a look at the first one that I already have written out. So notice we have one overall fraction, this larger fraction bar here, but then in the numerator we have a fraction, and in the denominator we also have a fraction. So that's what we mean when we have a complex fraction. This is an expression. There's no equal sign, so we're just simplifying the expression. So you're going to look at all of the smaller denominators. When I say smaller, I mean denominators of these fractions that are part of the numerator or denominator. So I have two denominators that I'm focusing on. They're both x squared. So that means that my least common denominator will just be x squared. So I'm going to multiply every single term that I see by x squared. And I have four terms, two on the top, two on the bottom. Every term needs to be multiplied by x squared because essentially what I'm doing is I'm taking the numerator and the denominator and I'm multiplying it by the same value. And remember, when we multiply the top and the bottom of a fraction by the same value, which in this case is x squared, we're not changing the value of this overall expression. We're just making it look different. It's also important to note that because x squared is in a denominator, x can't be 0, because that would make x squared 0, which would make this entire, this expression undefined. So it's okay that I'm multiplying by x squared because I know that there's no way that that is 0. So I'm going to distribute this x squared to each term. And when I do that for a fraction, remember we're only multiplying the numerator because this is essentially x squared over 1, right? So we just multiply the numerator by x squared. Same thing in the bottom. I'm just going to write down what I get. I'm not going to simplify yet, just so you can see each step along the way. So we have x squared times 1, which is x squared. Then we have x squared times 1 over x squared, which is x squared over x squared. Again, I'm just multiplying the numerator there. Yes, I can simplify, and I want to be able to simplify that, but I'll just leave that right now. In the denominator, multiplying x squared times 1, I get x squared. And then x squared times negative 1 over x squared, which is negative x squared over x squared. All right, so now I can simplify these fractions. So these denominators of those kind of subfractions are going to disappear. So this becomes x squared plus 1 over x squared minus 1. So now we just have a rational expression where the numerator is a polynomial, the denominator is a polynomial. I could check to see, and I should check to see, if this expression can be simplified even further by factoring. The numerator is the sum of two squares, which is not factorable. The denominator is the difference of two squares, but even though I could factor this, neither of those factors would end up canceling out with the numerator. So I'm not even going to bother factoring. I'm just kind of mentally thinking about, could I factor anything? And if I can factor, will any of those common factors cancel? If we don't cancel any common factors, then we can't simplify. So this is in simplest form. Let's take a look at the next example where we have, again, one overall fraction, but then two fractions in the numerators and denominators. So it's a rational expression within a rational expression. Let's go to our paper here. All right, so here I need to look at all of the kind of sub-denominators, the denominators that are in the numerator and in the denominator of that overall expression. So my denominators are a plus 1 and a. Remember, when we're finding the least common denominator, we're taking the product of all of the unique factors. So we have a plus 1 is not something that I can factor. It's a binomial, but the degree is 1 and there's no GCF. And here I have a monomial term. So the least common denominator would be the product of a times a plus 1. So I'm going to multiply the numerator and the denominator of this rational expression times a plus 1. So I'm going to write this out before simplifying, just so you can see what happens. There are some shortcuts that you can take and kind of simplify as you go. Remember, I'm taking this and I'm distributing it to each term in the numerator and in the denominator. All right, I'm not going to actually do any multiplication because I do want to end up simplifying. And remember, simplifying means factor first and then cross out common factors. So when I multiply this, I'm just going to write it as a product. So I have a times a plus 1. And that's over a plus 1. So this is just multiplying these two terms times this one term times this term here. And then minus. So when I multiply by 1, that doesn't do anything. So I just have a times a plus 1. That is the numerator. Again, I can simplify and I will simplify. I'll just do that in the next step. Here we have a times a plus 1 times a plus 3 over a minus 2 times a plus 1. This 2 doesn't have a denominator. The denominator is 1, so I'll just leave it like so. All right, so now I can simplify, and you should be able to simplify and get rid of these kind of small fractions that you have here. So this a plus 1 cancels out with a common factor in the bottom, and this a cancels out with a common factor in the bottom. All of these denominators should go away. That's the whole point. So when I do that, now I can go ahead and multiply these a's. A times a is a squared. If you did it before, it's fine. Here I will multiply this as well because I want to factor to see if I can cancel out any common factors once I simplify this numerator and denominator. So I will distribute that negative a. So it's negative a squared minus a, just distributing this negative a here and here. All right, the denominator, I want to multiply these two binomials together. So that gives me a squared plus 4a plus 3. And again, I did that quickly because I added the constants here to get the coefficient here, and then multiplied 1 times 3 to get this. Here I'll distribute that negative 2a, so it's negative 2a squared minus 2a. All right, so this is also that I could try to see if I can simplify. Simplify means factor and cancel out common factors when we're talking about rational expressions. So here I do have two terms that cancel each other out in the numerator. So I'm left with a negative a in the denominator. I'll slide this. Let's see, I'll put this down here. So I have a negative a in the numerator. In the denominator, let me combine like terms. So a squared minus 2a squared is negative a squared. 4a minus 2a is 2a, and then plus 3. Now I do have a negative in the top. The leading term is negative on top, and the leading term is negative on the bottom. So if I wanted to, I can factor out a negative 1. So just think about dividing top and bottom by -1, or you can write it in factored form, -1 times a. When I factor out a -1 in the bottom, it changes all of the signs for all of the terms. So now the -1's cancel. And I would like to see if I can factor this trinomial. I'm looking for two numbers that multiply to -3 and add to -2. Right, so if I had -3 times +1, that gives me a product of -3, and -3 plus 1 is -2. So I can factor that. Since I'm running out of space here, I'm going to write those factors directly underneath. Now, you might be thinking, why am I doing this? And really, I don't need to do this, because if I look at my numerator, it's only a. Neither of these factors are going to be a. So I know that I won't be able to simplify, but just to show you that factorization, now that we were talking about it, a minus 3 and a plus 1. But neither of those factors are going to cancel with the numerator that we have there. So our expression just turns into just this. Just running out of space, so I'll just box it off there. A over a squared minus 2a minus 3 would be our simplified expression. If you write the denominator in factored form, it's not wrong, but it doesn't make it any more simplified than it is in trinomial form. In the next video, see some more examples.